Hello student, welcome to digital classes. This video is for class 9 science and the chapter is 8 motion. This is the third video related to this chapter. In the last two video I discussed about distance, displacement, speed, velocity, distance time graph, velocity time graph, etc. Now in this video I am going to tell you about three equations of motion and circular motion. Now three equation of motion. First you take out a pen, pencil, notebook to write and understand the three equation of motion. Without writing you are not able to understand, so please take out your book, pen, pencil and watch the video carefully. While watching the video you have to write, means you have to drive three equation of motion to watch this video and raise a doubt in between the class. Before derivation of equation for motion with uniform acceleration means equation for the motion is only applicable when object is moving along a straight line with uniform acceleration. If the acceleration is not uniform, we are not able to apply these equation of motion. So the object is moving in a straight line with uniform acceleration, these equations are applicable. Now first I tell you what is the first equation of motion, which is v is equal to u plus at. Second equation of motion is s is equal to ut plus half at square, and the third equation of motion is v square is equal to u square plus 2as, or 2as is equal to u square plus v square. In the derivation of three equation of motion, we use initial velocity u, final velocity v, acceleration a, total time taken is t, and the displacement is s. First equation of motion. The first equation of motion is v is equal to u plus at, means final velocity is equal to initial plus acceleration multiplied by time. It gives the velocity acquired by a body in a time t. Consider a body having initial velocity u. Suppose it is subjected to a uniform acceleration a, so that after time t its final velocity is v. Now from the definition of acceleration we know that acceleration is equal to change in velocity upon time taken. So the acceleration is equal to final velocity minus initial velocity upon time taken. So a is equal to v minus u upon t. We transfer t to another side, means RHS side. So it is at is equal to v minus u, and then transfer minus u to the RHS side. Then it is v is equal to u plus at, means final velocity is equal to initial velocity plus acceleration into time. This is the first equation of the motion. Second equation of motion. The second equation of motion is s is equal to ut plus half at. It gives the distance traveled by a body in time t. Consider a body having initial velocity u and an uniform acceleration a for the time t, so that its final velocity become v. Let the distance traveled by the body in this time s. The distance traveled by a moving body in time t can be found out by considering its average velocity. Since the initial velocity of the body is u and its final velocity is v, the average velocity is given by average velocity is equal to initial velocity plus final velocity upon 2. Average velocity is equal to u plus v upon 2. Distance travel is equal to average velocity multiplied by time. So s is equal to u plus v upon 2 into t. From the first equation of motion we have v is equal to u plus at. Putting the value of v in equation 1, we get S is equal to u plus at multiplied by t and the whole upon 2, which implies S is equal to 2u plus at multiplied by t and whole upon 2, which implies S is equal to 2ut plus at square whole upon 2. Now we separate 2ut and at square. S is equal to 2ut upon 2 plus half at square. Now 2 and 2 cancel. So S is equal to ut plus half at square. Now the distance is equal to initial velocity multiplied by time plus half acceleration multiplied by time square. This is the second equation of the motion. Now the third equation of motion. The third equation of motion is v square is equal to u square plus 2as. I think square is missing in this, so don't worry. You just write v square is equal to u square plus 2as. It gives the velocity acquired by a body in traveling of distance s. Consider a body traveling initial velocity u and uniform acceleration a for time t so that its final velocity become v. Let the distance traveled by the body in the time s. The distance traveled by a moving body in time t can be travelled out by considering its average velocity. Since the initial velocity of the body is u and its final velocity is v, the average velocity is given by the third equation of the motion can be obtained by eliminating t between the first two equations of motion. From the second equation of the motion, we have S is equal to ut plus half at square. And from the first equation of motion, we have v is equal to u plus at. This can be rearranged and write as at is equal to v minus u and then t is equal to v minus u upon a. Now put the value of t in equation 2. Now t is equal to v minus u upon a and equation 2 is s is equal to ut plus half at square. Putting t is equal to v minus u upon a in equation 2, we get s is equal to u bracket v minus u upon a plus half multiplied by v minus u upon a whole square, which implies s is equal to u bracket v minus u upon a plus 1 upon 2a bracket a minus u upon a whole square. Now we cancel a square and a, the a is left over, which implies s is equal to uv minus u square upon a plus v square plus u square minus 2 uv upon 2a by using the identity a square minus a minus b whole square, which is equal to a square plus b square minus 2ab. Now we cancel positive 2 uv with negative 2 uv. Now minus 2 u square and plus u square is minus u square. Now the last step is s is equal to v square minus u square upon 2a. Now we transfer 2a to the another side, so it become 2as is equal to v square minus u square. Now we transfer minus u square to the RHS side, then it become 2as plus u square is equal to v square. Now this is the third equation of motion. V square is equal to u square plus 2as. Now equation of motion by graphical method means now we are going to discuss the equation of motion or the derivation of equation of motion by graphical method. We know that the three equations are v is equal to u plus at, s is equal to ut plus half at square, Third is 2as is equal to v square minus u square. Before driving the three equation of motion by graphically, I want you all draw this graph in your copy as I am explain these three equation graphically by using this graph only. Suppose a body is moving along a straight line with a uniform acceleration a. Let u be the initial velocity of the body at t is equal to 0. The velocity time graph of such a body is represented by a straight line AB that is shown in the figure. At t is equal to 0, the velocity is equal to OA is equal to u is equal to initial velocity, means that AO is the initial velocity and we use letter u for the initial velocity. In going from A to B, the velocity of the body goes on increasing at a constant rate, that is A, means acceleration. At t is equal to OC, velocity of the body is equal to CB is equal to V, means velocity of the body CB and which is equal to V. Now drop AD perpendicular to BC and BE perpendicular to OY. Now it is known that acceleration of body is equal to the slope of the velocity time graph. First I tell you about the slope of a line. Let m be the slope. M is equal to rise upon run. So the rise is equal to y2 minus y1. This is the two coordinates from the y. And run is equal to x2 minus x1, means these are again the two coordinates from the x-axis. In this graph, the rise is AE, which is equal to y2 minus y1, and the run is AD, which is equal to x2 minus x1. M is equal to slope and x1 and y1 coordinate of first point in the line, x2 and y2 coordinate of the second point in the line. Now the acceleration of the body is equal to slope of velocity time graph, that is AB. So AB is equal to rise upon sin, and the rise is AE and the run is AD. So AE is equal to V minus U and AD, which is parallel to or equal to OC, that is equal to T. Therefore A is equal to V minus U upon T. Now transfer the T to the RHS side, it becomes AT is equal to V minus U, and now transfer minus U to the another side, then V is equal to U plus AT. This is the first equation of motion and the derivation according to graphically. Now the second equation of motion graphically, the graph is same. Suppose a body is moving along a straight line with a uniform acceleration A. Let u be the initial velocity of the body at t is equal to 0. The velocity time graph of such a body is represented by a straight line AB shown in figure. Let s be the distance travelled by the body in time t in going from A to B. As is known, the distance travelled in such a case is given by the area of the space enclosed between the velocity time graph and the time axis, that is distance. Distance is equal to area of figure OABC. OABC is a trapezium. Therefore, area of OABC is equal to area of OADC, which is a rectangle, plus area of ABD, which is triangle. Distance is equal to area of OABC, which is equal to area of triangle OADC and area of triangle ABD, which is equal to OA into AC plus half BD into AD, which implies S is equal to U into T plus half BC minus CD into OC. S is equal to U into T plus half BC minus OA, which is equal to CD multiplied by OC, is equal to UT plus half V minus U multiplied by T, as A is equal to V minus U upon T, or V minus U is equal to AT. So we put in the equation, we get S is equal to UT plus half AT into T, which is S is equal to UT plus half AT square, which is the required position time relation. S is equal to UT plus half AT square is the second equation of motion, and this is how we represent the second equation by graphical method. Now equation for position velocity relation, as above in the second equation, the distance travelled by a uniform accelerated body in time t is given by the area of space enclosed between the velocity time graph and the time axis. Therefore, distance travelled is equal to area of OABC. Now, just before I tell you, OABC is a trapezium. Now, in the third equation, we use area of trapezium. Distance travelled is equal to area of trapezium OABC is equal to sum of parallel side upon 2 into distance between the parallel side. So, S is equal to OA plus CB upon 2 into OC. OC is the distance between the two parallel sides. S is equal to U plus V upon 2 into T. From equation 1, V is equal to U plus AT, V minus U is equal to AT, and T is equal to V minus U upon A. Now put T is equal to V minus U upon A in equation. We get S is equal to V plus U, V minus U upon 2A. So by using the algebraic formula A plus B, A minus B, which is equal to A square minus B square. So S is equal to V square minus U square upon 2A. When we transfer 2A to the another side, this is 2AS is equal to V square minus U square. Now this is the third equation of motion, which is required equation for position velocity relation. Now this is the method by which we derive three equation of motion by using graph, or we say graphically. Now I hope you all understand about the three equation of motion. Now I am going to tell you the last topic of this chapter. This is uniform circular motion. See, the first question is, what is circular motion? The motion of a body in a circular path is called circular motion. Now the uniform circular motion. When a body travels equal distance in equal interval of time over a circular path, its speed is uniform. The motion of the body is said to be uniform circular motion. The direction of the motion at any instant of the time is along the tangent to the circular path at that instant. To understand this, let us consider motion of a body along a closed path. Shows the path of an athlete along the rectangular track ABCD. The athlete changes its direction of the motion at four corners, that is ABCD, of the rectangular track. In every round, if the track is hexagonal or athlete runs around the hexagonal path, the direction of the motion change at 6 corners, that is A, B, C, D, E, F. And now if the track is octagonal, the athlete has to change the direction of the motion at 8 corners, A, B, C, D, E, F, G, H of the octagon. I show these figure at the last of this video. So you will check these figures in afterwards. We observe that as the number of side of track increase, the athlete has to take turn more and more number of times. If we go on increasing the number of side of track infinitely, we find that the shape of the track approaches the shape of a circle. The length of each side tends to be 0 along the circle. The athlete has to change his direction of the motion at each point. Therefore, the effective direction of the motion is along the tangent to the circular path at the point, as shown in this figure also. It should be clearly understood that in uniform circular motion, all the speed of the body is constant, but the direction of the motion of the body is changing continuously. Therefore, velocity of the body is uniform circular motion is changing continuously. Hence, the uniform circular motion is an accelerated motion. In the next chapter, we shall study about an external force is required to produce acceleration. Hence, an external force is needed to move a body uniformly in a circle. This force is called centripetal force. I repeat, an external force is needed to move a body uniformly in a circle. This force is called centripetal force. To circular speed of the body in uniform circular motion, r is the radius of the circular part, t is the time taken by the body to go once round the circle, v is the speed of the body in uniform circular motion. Distance travelled by the body in one complete revolution is equal to circumference of the circle. So S is equal to 2 pi r. Speed is equal to distance upon time. So V is equal to 2 pi r upon t. For circular motion, V is equal to 2 pi r upon t.